So it gives me great pleasure to be able to introduce to you today Keith Leung. So he's coming to us from Trimble and Applanix, but I've known Keith in, I think, many different guises. It all started when I first showed up as a professor at the University of Waterloo, and he was doing some fascinating research on matching satellite maps to rover trajectories, I believe. This is going way back now, and that was work, of course, with Chris Clark and Jan Hussoon. He then went on and did a really fascinating PhD with Tim Barfoot at the University of Toronto Institute for Aerospace Studies, and then spent three fascinating years, I'm sure, in Chile doing a postdoc. And he joined Trimble Applanix in 2016. And he's been there ever since, doing all kinds of fascinating collaborations with us and with other great researchers. And so we look forward to hearing about it. Particularly, I think we're going to be hearing about workflow autonomy, it sounds like. So a bit of a departure from the basic GNSS INS positioning that we know for so well. And so with that, I'll hand it over to Keith and look forward to hearing from him.
All right, thanks, Steve. Yeah, it's been a long time since I first met you at the ICRA in Pasadena. Well, thanks everyone for attending my talk today. So I wanted to speak about Trimble and our autonomy program and how that ties into what we're working on right now with my team at Applanix. So as Steve already introduced me already, I'm currently a senior engineering manager with Trimble Autonomous Solutions. This is our internal central R&D division across that serves the entire Trimble with autonomy research. So I think first thing that I want to talk about is the relationship between Trimble and Applanix. I think I get a lot of questions from different people asking me, so how are the two companies related? So Applanix is wholly owned by Trimble. Applanix was first founded in 1991, I think. Yeah, it's a long time ago. And around the 2003, Trimble bought Applanix. And that was the time when also when Applanix was starting to get involved in autonomy. So in 2005, 2006, the days of the DARPA Grand Challenges, all the winning, the top vehicles in the competition, they were using Applanix gear, the Applanix POS LV inertial navigation system. Those were GNSS aided. So that's when autonomy started. And fast forward to when I joined the company, then we started working on looking at using other aiding sensors for the INS. So instead of using GNSS, looking at using LiDARs and cameras. And then the autonomy program in Trimble also picked up speed on the agriculture side and the construction side. There's been a lot of work. Traditionally, Trimble has a strong presence in agriculture. So I'll show you some of that work today. But where I want to start is looking at, when we talk about autonomy in Trimble, is to look at the SAE levels of autonomy. So this list is not the real definitions. This is just my interpretation, a simple interpretation of it. We have from level 1, where it's just only driver assistance, driver is still responsible for everything. Then gradually we can go from hands off to eyes off and mind off. And then at the top level, level 5, this is our the part where all vehicles can be driving anywhere autonomously. And we sort of talked about that during Monday's AV workshop. We were there, and how big of a challenge that is. So if we look at Trimble and where we stand, we look at autonomy not just from the vehicle's perspective. We like to look at autonomy in terms of the workflow that we can provide to our clients. And ultimately what we want to do, we want to provide value by optimizing operations and workflows. So there is, at the bottom level, operator assistance. That's something that's sort of coincides with also the level 1 SAE level of autonomy. Then we get into things like task automation, which in agriculture, for example, we can do automated spraying. For construction, we can do automated blade control for grading vehicles. And as we go higher up, this is about approximately where we're at right now with supervised autonomy, where we're essentially driving autonomous farming vehicles or construction vehicles, and to make the lives of construction workers or farmers easier. And then ultimately, what we want to do is tie that into our ecosystem, Trimble ecosystem for agriculture and for construction, and that's what we call it for workflow automation. So in agriculture, so as I mentioned, Trimble has a large presence in agriculture. So my team, we do a lot of work in localization and perception, and a lot of the videos that I'm showing today, I'm trying to avoid showing the corporate marketing videos and show you more of what the engineers are working with, and the results that we're seeing. And so, and my team work a lot on, again, perception and localization. So we've done some work in orchards and vineyards, and localizing vehicles that are used for spraying in the orchards. So a lot of interesting work in California. This is very useful because of the shortage of operators, and especially in orchards where there are high value crops in California, like especially like walnuts. They really need, they want to automate this driving process because of the lack of operators. Also in agriculture, we're doing a lot of work in spraying large crop fields. So detections of crop rows, that's something that we've been working on. And that's something that Trimble has been doing for quite a while now, but based on GNSS. And as I mentioned before, we want to bring in other perception sensors, robotic sensors such as cameras to do as another source of information for that operation. On the right video here, that's something we're working on for people detection in vegetation. That's something that it's always on our mind, safety. We're always worried about people hiding in, or just being in the operation area of an agriculture vehicle and accidentally running them over. So that's something related to machine learning that we're working on right now. Yeah, so I mentioned about the workflow, automated workflow, and then having autonomous vehicle integrated into that. This is one of our engineers' workstation. Because of COVID, he brought everything to his house. And this is the hardware in the loop simulator that we have for our agriculture sprayer. So it's not only about controlling, again, our work is not only about controlling the vehicle itself, but looking at the entire workflow, looking at work orders that come in that is necessary to fully service a farm. All right, so aside from agriculture, construction is another big sector that Trimble is operating in. We've been doing a lot of work on compactors, the vehicles that, as you see in the video here, they have different types of drums in the front that they essentially compact the ground. And again, we've done work for mapping and localization. Now, in a sort of open sky environment, GNSS works really well, and the reason why we are bringing in other sensors is for situations where these vehicles might be operating close to urban environments, under bridges, other infrastructures where that GNSS signal gets degraded. And because these machines, we're talking about centimeter precision, it's important to get the positioning right for these vehicles, the precision estimate, so that they do their job properly. This not only goes for compactors, but also grading vehicles. So this is exciting work. It's gives us a lot of opportunities to do field deployments on various vehicles. I got to drive one of these compactors and it was super fun. The ride is also surprisingly rough. And one of the problems we have is choosing appropriate sensors to use for these vehicles. If we put a regular Velodyne LiDAR on one of these vehicles, they tend to break down fairly quickly because of all the shock and vibration. It's one of the big things we're working on right now is a safety certified stopping system for a compactor. This is a radar-based system. So on the surface, it looks fairly simple, right? You have a person walking in front of a vehicle, it stops. It doesn't have to do anything else. But the safety certification part is the complicated part. Code has to be written a certain way, analyzed and line by line. And so this is a long process, but it gives us some guarantees, or our clients some guarantees on the performance of the system, and that it's a system that they can trust, and the rest of our autonomy stack can sit on top of. So in having an autonomous compactor, what we want to do is connect that with Trimble construction ecosystem. And so the idea is to having this capability of running an autonomous compactor, have it assign work orders that someone can upload to the machine through Trimble Cloud. And so someone will, an operator can specify a compaction area. And once that's defined, our planning software will automatically plan out the path that the compactor drive, and then the vehicle will execute that path. This is, this right now, it's a simulation that we're running. I'm showing you, but we also have that. We're also able to do this in real life. All right. So aside from agriculture and construction, we also work with other industries as well, heavy industries. Mining is an area that we're actively working in. So Trimble has a joint venture with Caterpillar called Caterpillar Trimble Control Technologies, and working on technologies for mining vehicles. We've done some work in underground mining. This is again showing from work from my team doing mapping and localization in an underground mine. It's been, yeah, this is actually a mining tunnel in Sudbury that we visited a few years back. We're also working, operating in open pit mines. Now this video is interesting. It shows you some of the difficulties that we experience in open pit mine. So we see a haul truck passing on the left side, and we can detect that it's a haul truck, label it momentarily. But then because of all the dust that it kicks up behind it, while we're following the vehicle, we actually lose track of that vehicle. So this is, yeah, dealing with dust and adverse weather conditions. That's something that we need to work on. Now you might say that, why don't we just add other sensors onto these vehicles, such as radar? Part of the problem is when you add sensors on vehicles, on the side of vehicle maker, it takes a really long time for them to certify that sensor for use, especially for a production vehicle. That's a process that can take many years. So we try to work with the sensors that's already exist, that's there already. In this case, it's a fairly it's a LiDAR, 64 beam LiDAR. So here, yeah, as the vehicle comes up from a dust cloud, momentarily we pick it up again, but then as soon as we're following back in its trail, yeah, we lose track. So Aside from mining, in manufacturing facilities, steelworks, we've been doing a lot of work. We like operating in these areas because it's so well structured and localization works really well. Typically, for localization, LiDAR-based localization, we can most of the time where we can get accuracies of under 10 centimeters. About 50 percentile error is about 2.5 centimeters. So it's on par with GNSS. So Trimble, yeah, although a lot of the work that we have shown is for off-road, we do operate on-road. We do supply our correction services and GNSS and inertial navigation systems for the automotive market. So the GM Super Cruise is a system that uses Trimble technology inside. It uses the RTX correction service, and what's special about it is that it's safety certified, ASIL certified, and how it works is it's delivered by this correction service delivered by cellular. So even if you're in an area where you don't have a direct connection to a base station, you still get that correction service. But then, of course, what happens when let's say, you're driving in a tunnel, and that's something else we're working on right now, is doing map-based localization for on-road and using that solution as a separate aiding source for our inertial navigation system for on-road. This is an interesting data set. This is from the roads of Paris, where we're actually working with the Trimble geospatial team. They have created a new mapping LiDAR, and then they're interested in using our SLAM technology. So aside from sort of our main autonomy division, our technology also is used in other Trimble divisions as well. So, all right, and this is the last video that I'll show. So this is in a light rail application. It's very similar to on-road in that there are situations where GNSS signal is degraded when we're traversing sort of between trees in the forest. Signals can get heavily degraded, and this is where LiDAR-based map-based localization is really useful for us. All right, so yeah, hopefully that gives you a good taste of what we work on at Trimble and what Trimble Autonomy is about. Part of the reason why I'm giving this presentation is because we're always looking for good talent. We're expanding rapidly, and not only in our Toronto office of Planix, but also our offices as well in Denver, Colorado, and Atlanta, and Sunnyvale. So I know there's a lot of smart people attending this conference. If you're working in perception, in navigation, SLAM, LiDARs, cameras, radars, and you're interested in what we're doing in off-road autonomy, please reach out to me. We have a lot of positions open right now in various locations. So, yeah, and with that, I'll end my presentation. Thank you for your attention.
Awesome. Let's join in and thank our speaker. Way to go, Keith. Really nice. All right. Feel free to unmute and clap if you want, people, or just do the reactions. Nice. There's Ian. Well done. All right. So that was really nice. What a wonderful set of maps we got to watch build and fly by there in every different application, and neat to see you know, different aspects of autonomy coming into the Trimble and Planix stacks. That's great. Are there any questions from the audience? We do have a little bit of time. I'll give them a few seconds to remember from all the awesome videos. So you were showing a really nice example of how sensor degradation in adverse conditions leads to failures of detection systems. There are some methods out there that work, and we've been talking about them at this conference a little bit. What sort of things, we're curious about what sort of things you tried to overcome those dust clouds behind the mining trucks?
So I think well, as I mentioned, we don't get to choose the sensors in this case. With the sensor setup on the vehicle is set, and that's what we have to work with. And we have tried applying different sort of filtering methods to eliminate that cloud, but sometimes that it's just so dense, that cloud of dust is so dense that it's even if you can filter out that part, what you see oftentimes it's just the top of these haul trucks, and it's just a little portion of it, and from that it's it's still really difficult to detect or confidently detect that this is a certain haul truck, a certain model of haul truck. Yeah.
For sure. Although it hasn't disappeared, right? And that the dust cloud is kind of affirmation that it's still there.
Right.
You must be able to infer something that way. All right, I'll pass it over to Ulushu. Go ahead. If you want to unmute. We have a question. Let's just give him a second. He did raise his hand. All right. Oh, we've got a question from Sandeep. Do you have any way to share data from agriculture surveys for academic research?
Sorry, I will come
there you are. Yeah, why don't you go
sorry.
ahead? You go ahead. No
I
problem.
forgot to unmute. Can you believe?
Yeah.
So, Keith, many thanks for this beautiful representation of Trimble. I have always considered this company to be really one of the best surprises in technology in the last 2 years. So the question I'm asking is, do you have an overall platform that is integrating everything, a kind of smart farming platform that can be used by us academics to do research on? I'm asking the question because we do research on smart farming with a facility here in Ottawa that is called Area X.O that is financed by the government and has put together really lots of what can I say, data gathering platforms and pieces and communication platforms and so on. And we are trying to piece that together into an overall platform, a smart farming platform. And we use many of your data gathering platform. And I'm just wondering if you yourself have an integrating smart farming platform that can be used. That was my question.
Okay, so in terms of the hardware, I would say so. Trimble works primarily on the software stack for any autonomous farming vehicle. We don't have one that we sell. So what we typically do is we've been partnering with the various agriculture vehicle manufacturers such as Porsche. Like we're doing a lot of work right now in the Czech Republic and with that company. So yeah, we don't make our own vehicles, our own platforms. And what we do is we primarily provide parts of our autonomy stack. So if you have a platform already, I think it's what we can discuss is providing parts of our autonomy stack that you can leverage, you can use.
Yeah, absolutely.
Yeah.
We use Microsoft platform. That's the starting point that we are using. So FarmBits, probably you know it. Yeah. So we will reach out to you.
Okay.
And I sent you my email already in the chat.
Okay, great.
Thank you.
Excellent. And Sandeep, why don't you go ahead? Yeah.
Yeah, I'll just ask the question. Steven already read the question, but then I'll just put it again. Like, it was a great talk, Keith. I just wanted to understand, like, if you have any ways to share the data with academic labs for academic research, is that a possibility, or like how to reach out for that?
Yeah, I think it is possible. It depends on what kind of agriculture data that you're looking for. Are you looking for things like an open like crop rows and fields? Are you looking for things in the orchard? What type of data are you looking for? There's
we are looking for, like, we are basically working on planning algorithms for agriculture applications. So any of these data, either like the health data or even the vision data from any of these orchards, or even the like row crops, that would be great. So I can reach out to you on details, but I just want to know if that's a possibility.
You could. Yeah, we can talk offline about it. The only thing I would say is we probably can't share any of the data that we have from our clients, but any data that we collect in local from ourselves in California or in Colorado, I think we can. It's easier to share that type of data, but we can take this conversation offline.
Okay, I'll reach out to you. Thanks.
It does indeed seem like a difficult localization problem, right? With all of those sort of repeated trunks and highly variable leaf and branch structures, it's got to be a tough matching problem. So it must be hard to rely on LiDAR alone.
Yeah, definitely. And if you make one mistake, you can be off by meters.
Right.
Right.
Yeah. I guess odometry and IMU is going to help a lot, I guess, with the rejection of some of the errors. Is that right?
Yeah. The other problem with operating in the orchard is a lot of branches and that stick out.
We're just getting hit by them.
Yeah, your sensors will definitely get scratched up, and we've scratched up many Valdyne LiDARs.
Absolutely. Yeah, absolutely. The real world problems. Okay, are there any other questions for Keith? Last chance. All right, wonderful. Well, thanks so much, Keith. That's really nice to get another good glimpse into the Trimble Planix efforts, and I look forward to seeing more in the future.